All right, this is our lesson from April 6th, predicting products. Mr. Glass, I got my daughter Marcella here with me, so we'll see what wonderful things she puts onto this recording. Moving on, we're going to be using what we did last week with balancing equations and types of reactions to basically fill in the blank that would be the second half of the reaction. We're going to look at the first half and tell from that exactly what's going to be on the second half. And to do that, you need to know your 5 types. You need to be able to identify your 5 types, right? Synthesis has 2 elements in the beginning. Decomposition will have 1 compound in the beginning. Single replacement has an element and a compound. Double replacement has 2 compounds. And combustion, you're going to have fuel and oxygen. So you need to be able to identify those just from the first half, which each one is different, so it should work out. Now, to create the second half, you need some basic skills. We need to know the standard charge on all of our ions. We need to know our monatomic and our diatomic elements, and we need to be able to create compounds. So you should be able to look at sodium here and tell that it's a +1, or a 1+, I should say. Magnesium would be a 2+, oxygen would be a 2-, bromine would be a 1-. And you can tell that just by what column they're in the periodic table, but it's a skill that you should have. Also, our monatomic and diatomic, you notice that Cl should be Cl2 whenever it's by itself. Oxygen should be O2 whenever it's by itself. And iron and sulfur stay iron and sulfur. There is no 2 at the end of it when they're in their elemental form. We know those 7 elements from Cliff H. Braun. And then creating compounds. If calcium's a 2+ and fluorine's a 1-, you should be able to tell that it should be CaF2. The 2 goes on the F because I need 2 fluoride ions to add to the calcium ion, which is has twice as much charge in the opposite direction, so that the compound adds up to 0. Basically, you're swapping and dropping. So since on the next one, the 2 is with the O, I'll need 2 Ks. It would be K2O. And then ZnNO3-, you'll see that nitrate, the NO3-, only has a -1 charge, so it's going to get a 2, but it's already got a 3 at the end. So we're going to write it as zinc parentheses NO3 2. And then aluminum oxygen, switch those around, Al2O3. Both of those, if you have 2 aluminum, that will give you 6+, and oxygen, 3 of those would give you 6-, adding to 0. So those are just some basic skills you should have before you move forward from here. This should look familiar. Synthesis, what we're going to be looking at is we're not going to have the second half. We're not going to have that compound at the end. So it could be AB, like is shown. It could be A2B. It could be AB2. We don't know. We have to decide based off what the charges of A and B are. So it's all about what those charges would be. So taking for an example, I've got magnesium and oxygen right here. Trying to get my pen tool, excuse me. Which is Mg and 2 O's. We've got to look at magnesium's charge and oxygen's charge. So magnesium should be a 2+ on the periodic table. Oxygen should be a 2- on the periodic table. So I'm going to take that into consideration. How do I undo an annotation? That's a great... There we go. Well, I deleted them. So, no, I want to keep those, and I want to continue on with the lesson. This is great. Okay, now we're back. So, you got magnesium and oxygen. We've got Mg and we've got O2. And we've got this Mg2+ and this O2-. Now those add up to 0, so we'll just put those 2 together and call it good. Now if you look, well, there's not as much oxygens on each side now, so we will balance the reaction later after I write the MgO with its balanced charges. Not necessarily the balanced entire reaction though. So what we'll do is we'll add a couple 2's in there, so that I end up with 2 magnesiums on the left and 2 magnesiums on the right, thus giving me 2 oxygens on the right as well. Here's another example. We've got barium and nitrogen. Notice how nitrogen is a diatomic element. It's got N2 on it, right? But we don't need to know that for predicting the product, predicting the other side. What we need to know is what are the charges I'm dealing with. Well, I've got barium and I've got nitrogen. If I look those up on the periodic table, barium is a 2 plus, nitrogen is a 3 minus. So to get those to add up to 0, I'm going to need 3 bariums and 2 nitrogens combining into a compound that I will write as a formula Ba3N2, because there are 3 bariums and there are 2 nitrogens. Then a simple balance, and I'm done. So here's some for you guys to think about as you're going through. We've got K and F2, we've got Mg and I2, we've got Ca and N2. Now, a lot of people will just smack them together and call it KF2, MgI2, and CaN2. If you did that, you would only have one of them right. Hello. There's the pen. All right, awesome. So look up the charges. You'll see that potassium's a 1 plus, fluorine's 1 minus. Here I have a 2 plus and a 1 minus, and a 2 plus and a 3 minus. So what are these formulas going to look like at the right? Well, potassium fluoride is going to be just KF. Well, we'll just leave that mark there because I forget my pens there sometimes. MgI2 is going to arise from the Mg being a 2 plus charge. And Ca3N2 is going to come about because those charges are just so awkward that you swap them and drop them to tell what that compound's going to be. Decomposition reactions. Now this time it's the opposite, right? We're going to get the compound and we got to write the elements. So it's going to take a whole different skill. What we're going to do is we're going to have gold fluoride here, right? So we've got gold with 3 fluorines around it. But I don't care about the subscripts right now. Doesn't matter. When I'm writing just elements, because I'm going to get potassium and I'm going to get fluorine, right? When I'm writing just elements, what I'm going to care about is whether they're diatomic or monatomic, whether they come in one atom form or they pair together. So the gold is singular and the fluorine pairs together because of Cliff H. Braun, right? Fluorine is part of those 7 elements that I need to memorize. So you've got Au plus F2, and then a simple balance will tell you that there is a whole lot more to this reaction, right? But it is essentially gold fluoride becoming gold atoms and fluorine atoms, separate, hence being a decomposition reaction. So here's a couple more to look at. You got N2O, Ag2S, and CaCl2. So for these, what I'll do is I'll look at the 2 elements together, and I'll figure out whether they're diatomic or monatomic. For N2O, both nitrogen and oxygen are diatomic. For silver sulfide, none of them are diatomic. And for calcium chloride, only the chlorine is diatomic. So these are the possibilities that you could run into as you're going through. Basically, you're going to write the element, and you're going to put a 2 at the end of it if it's one of those 7.